Hey guys, so now we're talking about mathematical modeling. So this is a part of the real power of mathematics. It's not just crunching numbers, but it's being able to look at a situation or a problem in the real world, being able to lay a mathematical frame over that, get quantifiable answers and results. So the basic 4 steps that we're going to do, and I absolutely expect you guys to copy this chart. Okay, I expect you to memorize and know this process. So first is we have some real world problem. All right, from that we formulate a mathematical model that represents the important aspects and attributes of our real world problem. Once we've formulated an appropriate mathematical model, or at least what we think is appropriate, we go ahead and solve. So we've made this mathematical model, and then we work out a solution that gives us a quantifiable and actual numeric best result. So we take that solution of our mathematical model and then we interpret what do those numbers mean, what does that solution mean in the context of our real world problem. Now we feel like we have the solution, we think we have an optimal value or whatever we're looking for, and then we test it against the real world problem. Alright, so lots of fields do this. In computer science it's called alpha testing or beta testing. Engineers constantly have to do this. Anybody who's trying to solve a problem, you may do all this process seemingly correctly and thinking that you've done it, but when the rubber meets the road when you test it against the real world problem, see how your solution really fares. Alright, so this is your paper, fill that in. Alright, so when talking about mathematical models, we're going to talk about what a function is. Let's first discuss that in comparison to a relation. Alright, a relation is just any rule that assigns x's to the y's. So basically it can be a set of ordered pairs. It can be a formula or a function. It doesn't have to be. Just any rule, even if you just explicitly say 2 goes with 15, 6 goes with 11,000, right? You can make up any rule, and that's technically called a relation. A function is a specific relation in which every input, so here's the key, every input has only one output. Only one output. So basically, if we go back to algebra class, where these were our inputs, x's are our inputs, y's are our outputs, you can never have one element in your x, let's say a 1, go to 2 different things in your output. So if you plug in a 1, you're only going to get one answer. If this kind of thing occurs, that is not a function. Okay? Also, if you have 2 different outputs, you know that they had to come from 2 different inputs. Basically, every input has only one output. That's the rule for a function. So let's talk about our independent variables versus dependent. The independent variable is what you're free to choose. The dependent variable, really you want to think of independent and dependent variable. The easiest way to figure it out is to think of this sentence here. What depends on what? Alright, as soon as you can make that sentence, it's the y that depends on the x. It's the output that depends on the input. So you could say, for instance, money that I make depends on the hours I work. In that case, the money would be the dependent variable and the hours you work would be the independent variable. You're free to choose, or sort of free to choose, how many hours you work, and then that determines what you make for your money. Alright, so your domain is just the set of possible inputs. Right, so in this course, everything has a context, right? We do some nuts and bolts problems, but everything has a context. So within our context, that will limit our inputs very often. And then the range are just all the possible outputs once you plug these things in. Alright, so a function, every input has only one output, so it has to look something like this. Or you could even have a bunch of inputs all go to the same output, that's fine, because 1 only goes to 5, 2 only goes to 5, 3 only goes to 5. It's this picture up here that can't happen. So a linear function is mainly what we're going to be studying currently, and a linear function it's a line, it's a direct relationship. There's a direct proportion between the change in x and the change in y. Alright, so the change in y over the change in x is constant. So not linear would be anything with like an x squared, anything with like a square root, anything that's not just y equals some number times x, maybe plus or minus a number. Okay, these are not linear.